Assalamualaikum everyone. Today we are going to show how an ultrasonic sensor works using an Arduino. To complete this procedure, we need firstly an ultrasonic sensor which model is HCSR04. Then we need an Arduino R3 as the controller. We also need a laptop. Finally, we need some jumper wires to complete the connections. Here in my hand is an ultrasonic sonar sensor. There are 4 pinouts in an ultrasonic sensor. From top to bottom, the pinouts are here, we can see that. VCC pins, trick pin, echo pin and the ground pin. Ultrasonic sensor is used for measuring distance, however it can only measure the time. It maintains simple distance is equal time into velocity formula. The sensor can measure from 2 cm to 400 and its operating voltage is 5 DC volt. Firstly, for VCC pinout supply powers to the sensor. Then there is the trick pinout comes, which is used to trigger ultrasonic pulses. By setting this pin to high, the sensor creates an ultrasonic burst. After that, there is echo pin and it is used for receiving the transmitted burst. After receiving the burst, the sensor goes from high to low. When the echo pin is measuring the time, it stays high. The distance can be calculated by it. Finally, ground is the pin connected to the ground of the Arduino. Now, here in my hand, it's the Arduino. These are the analog inputs and here the digital outputs. DC is used for connect the Arduino with the laptop. These are male to female jumper wires. The male sockets are connected with the Arduino, whereas the female sockets connected with the sensor. Now we are going to connect the sensor with the Arduino with jumper wires. This is how we have to connect the jumper wires with the sensor. We are going to connect the VCC pin with the 5 volt pin of the Arduino. There are 2 ground pins in the Arduino. Any of it would work properly. Now we are going to connect the ground pin with the ground pin of the Arduino. After that, we are going to connect the trick pin and echo pin with the digital input and output in the Arduino. To complete the procedure, we are going to need an Arduino IDE software. Here's the software we can see in the monitor. We have already opened it. We need a code to run the sensor, so now we are going to write down the code. The code is now done. Now we are going to connect the Arduino with the laptop. Here, pin 7 is trick pin as the input and 8 is the echo pin as the output. The distance needs to be in store, an integer variable which is referred to as float distance and float duration. They represent the real numbers approximately using an integer with a fixed precision. The trick pin must be put to a low state for just 2 milliseconds in order to ensure that it is cleared before beginning the loop. Now we must place the trick pin on high stage for 10 microseconds in order to generate the ultrasound wave. As we previously indicated, we will multiply the duration by 0.034 and divide it by 2 to obtain the distance. And by delay, it means the loop will run twice in 1 second in regards to the fact that a signal will be generated within 500 milliseconds and then received with another 500 milliseconds. The distance figure is being displayed on the serial monitor by the conclusion, and here it is. Here is our ultrasonic sonar sensor and this is our obstacle. Let's measure the distance of our obstacle with the sensor. On the screen, we can see the distance of the obstacle. If we move the obstacle backwards, the distance will change and is shown at the display. So this is the process to measure the distance of an obstacle using an ultrasonic sonar sensor.